arithmetic sequences, sometimes called arithmetic progressions. Here we can see the formula to find the nth term. What do these mean? Well, un means the nth term. So if we had a sequence which was 1, 2, 3, 4, then the fourth term would be 4, the fifth term would be 5, etc. If we had another sequence, 2, 4, 8, 10, the second term would be 4. We use the letter A to represent the first term, and we use the letter D to represent the common difference, and L for the last term. Let's look at an example. Here we want to find the first 5 terms of this sequence. So for part A, we know that the first term is called U1. It is also called A. And this, filling this number in, 2 times the 1 gives us 53. To find the second term, we replace the n with a 2. 55 minus 2 times 2 gives us 51. Now once you've done at least 1 or 2 by hand, showing you're working, you can at this point skip on to just write the answers in. You could do this using your calculator or just in your head. So that gives us 49, 47. At this point you might notice that we're just subtracting 2 each time, which is our common difference. Next, we want to find the 99th term in the sequence. To do this, this was n equals 99. So we do 55 minus 2 times 99, which gives us an answer of negative 143. So terms of a sequence can also be negative. For part C, we want to find the first term in the sequence that is negative. Well, we want to know the term that is negative. So negative being less than 0. We want to know what the n is in this case. We can replace this with 55 minus 2n is less than 0. 55 is less than 2n. Divide both sides by 2 and we get 27.5. Now this can be written the other way around, so n is bigger than 27.5. However, we should note that terms of a sequence, we can have the first term, the second term, third term, etc. It doesn't make sense to have the 27.5th term. So therefore, the first term is when n is equal to 28. And you could take a moment and check this. Moving on to example 2. Find the nth term of each arithmetic sequence. Well, for part A, we know the formula is un equals a plus n minus 1 times the common difference. So for the first one, we know that the first term is 6, and hopefully you can spot the common difference is 4. Sorry, 14, apologies. So we have n minus 1 times 14. At this point, you would be expected to tidy this up. So 6 plus 14n minus 14. So we're left with 14n minus 8. Doing the second one, we can see that a is equal to 101. This time we're subtracting, and hopefully you can see we're subtracting 7, so the common difference is negative 7. So un is equal to, again, writing this formula down to help us remember it. So un is equal to the first term plus n minus 1 times negative 7. Expanding that out, we have, that should be a negative 7n plus 7, being really careful with those directed numbers. And then finally, tidying that up, we have 108 take away 7n, giving us that answer. On to our third and final example. In this case, we'll note that we have been given 2 bits of information. So I'm going to write those down first of all. U3 is equal to 5 and U8 is equal to 20. Now, in this case, we've been told that the sequence can be written in this form. So let's use those 2 bits of information. So we know that 5 is equal to A times 3 plus B. And the second one, we know that 20 is equal to, n is 8 this time, so 8a plus b. And we've formed a nice easy simultaneous equation, subtracting one from the other. In this case, I'm going to subtract the top one from the bottom, giving me 15 is equal to 5a, and the b's cancel. Dividing both sides by 5, I get a to equal 3. Now I can sub this back into one of my equations. I'm going to choose the first one, so I'm going to write 5 is equal to 3 times my a value of 3 plus b. So 5 is equal to 9 plus b, so negative 4 is equal to b, so therefore b is equal to negative 4. And I have my 2 answers.